So we were working on a particular problem. So let's go back to the problem. An archaeologist discovers 7 fossil skeletons from a previously unknown species of miniature horse. Reconstructions of the skeletons of these 7 miniature horses show the shoulder heights in centimeters to be. Well, these are the 7 different shoulder heights. From these sample data, we calculate the mean x bar and the standard deviation s. Now, let mu be the mean shoulder height in centimeters for this entire species of miniature horse. Now, that's a huge number of miniature horses. Now, assume that the population of shoulder heights is approximately normal. So, that's an assumption we have to make. Now, find a 99% confidence interval for the mean mu, the mean shoulder height of the entire population of such horses. First, we need to check some requirements. Assume that the shoulder heights of the reconstructed skeletons form a random sample. Okay, we have to make that assumption that it is a random sample, right, of shoulder heights for all the miniature horses of the unknown species. Next, the X distribution is assumed to be approximately normal. We don't know the standard deviation for the population. It is appropriate to use a student's t distribution and sample information to compute a confidence interval for mu. We have 7 in our sample space, so our n is 7. So degrees of freedom is n minus 1, that is 7 minus 1, that is 6. C is 99%, so 0.99. That 9 should not be there, okay? So 0.99. T of 0.99 is 3.707, right? So let's remind ourselves how we come across. So 0.99 and degrees of freedom is 6. So 0.99 is C, degrees of freedom is 6. So I get TC is 3.707. So TC, T of 0.99 is 3.707. We already know standard deviation is 1.19. That was calculated earlier. All right. So you have TC and you have S, you have N. You can now calculate the error tolerance or the maximal margin of error using this particular formula, which comes to approximately 1.67. So the 99% confidence interval is x bar plus mu, x bar minus E to x bar plus E. All right. So that's your confidence interval. Okay. How do we interpret this result? We interpret this by saying the archaeologist can be 99% confident that the interval from 44.5 centimeters to 47.8 centimeters, those are these two numbers, is an interval. So we are 99% confident that this interval is an interval that contains the population mean mu for the shoulder height of this species of miniature horse. Okay, so we are 99. So the way we would interpret is 99% confident that this interval is an interval which contains this population mean. Okay. Summary. Assume that you have a random sample of size n. Okay, you have a random sample of size n from an X distribution and that you have computed x bar and s. A confidence interval for mu is x bar minus e less than mu less than x bar plus e, where e is the margin of error. How do you find E? It depends on how much you know about the X distribution. So here we go. You don't know the population standard deviation. In this case, we are going to use the student's t distribution. E equals TC S over square root n with where degrees of freedom df is n minus 1. Although a t distribution can be used in many situations, you need to observe some guidelines. If the sample size n is less than 30, X should have a distribution that is mound-shaped and approximately symmetric. You must at least have this, if not outright normal. It is even better if X distribution is normal. If n is 30 or more, the central limit theorem implies that these restrictions can be relaxed. That is, we don't have to require X to be normal. All right. Situation 2, which almost never happens. And what is that situation? You actually know the population value of sigma. In addition, you know that X has a normal distribution. If you don't know that X distribution is normal, then your sample size is 30 or more. In this situation, you use the standard normal distribution Z, and margin of error is then use the critical value, you see, ZC, sigma over square root n. So, which distribution should you use for X bar? First, examine the problem statement. Check whether mu is known or mu is unknown. If mu is known, use normal distribution with margin of error this. If mu is unknown, use student's t distribution with margin of error this and degrees of freedom n minus 1. All right. So this completes section 8.2 theory. Next videos will cover problems on the section. Okay. Until then, bye.